Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. And we got a great show this week. We're going to learn all about Foxboro's brand new DCS. But before we get to that, I have a couple of announcements. First, I want to thank Schneider Electric for sponsoring this episode so I can release it completely ad-free. And I also want to thank those of you who are my members at YouTube or on the automationblog.com who make it possible for me to do shows that are not sponsored by the vendor. We have a number of those coming up. And I just want to let you guys know I got even more stuff coming. I know we have over 12 member-only videos so far this year, but I have even more stuff coming for you guys that I'm working on nights and weekends that you should see in the next couple of months too. So thank you for being a member either on YouTube or theautomationblog.com. And with that said, let's go ahead and jump into this episode of the Automation Podcast and learn all about Foxboro's new DCS. Elias, thank you for coming on the Automation Podcast. Appreciate you making time to tell us about this exciting new announcement from your company. But before we get into that, if you could you take a moment and introduce yourself to our audience?
Yeah, absolutely. It's great to be here, Shawn. My name is Elias Panasuik. I look after offer enablement for our process automation business here at Schneider Electric, and super, super excited to talk to you. I've been with Schneider for coming on 14 years, and I've been in this industry for the better part of 20, so virtually my entire career. And this is, the first time certainly I've been a part of something this monumental. In terms of what we've recently launched, which is the world's first open software-defined DCS system, and that's Foxboro SDA. I live here in Massachusetts. My office is in Foxboro, and again, this is all very close to home. So, as we were chatting with yourself, Shawn, and with others, from an analyst standpoint and out in the market. Certainly the feedback that we've had thus far has been very positive, and also from our customer base as well. And certainly these things don't happen by accident. There's lots of customer input. But now that we have a wider audience for this, that we've launched this publicly, it's great to have an opportunity and a forum to talk to you and of course to your audience on this topic.
Yeah, and I appreciate you coming on. Go Pats. All right. So everybody knows I'm in the
That's right.
Berkshire, so about 2 hours away from Foxborough. And of course, you always root for the local team. Most people do. But in any case, yeah, very excited to have you on. I talked to one of your senior vice presidents recently at the Innovation Summit about openness and some of the strategies they're using on the other side of the company. And, as we think back, I also am one of the hosts of the Automation Museum, a History of Automation podcast. And one of the things, we look at when products first came out, there were no standards. And so companies had to create new products that addressed what was happening in the field. But over time, when multiple companies were producing multiple products, that's when, people started saying, wouldn't this be great if they could communicate to each other? And then standards started coming out. We started seeing open networks. And now we're in the age, it seems like, of open automation, where actually platforms like the one you're going to talk to us about have openness built into it, right? And so the design from the ground up to be, I don't know, flexible, easy to access, easy to connect to. And so, we heard previously in a previous podcast of what that means more on the smaller discrete side of automation. So now as we take a look at distributed control systems, process automation, and those types of fields, can you tell us a little bit more about what you're launching, what you just launched?
Absolutely. And so a lot of those fundamentals that you talked to Hanny about on your most recent podcast on this topic, a lot of those fundamentals is really the philosophy that we took from the very beginning when we were designing and coming up with the concepts around Foxboro SDA. And so I'll just kind of reiterate a little bit what those concepts are. One is flexibility and freedom in terms of hardware selection. So we will continue to produce automation processors, I/O, and the various components that go into a distributed control system network. But there's also the challenge that comes with existing systems, whereby the software, the runtime, is always tied to a very specific piece of hardware. So what that means is, when we as a manufacturer or one of our competitors are dealing with an end of life or a chipset challenge in terms of manufacturing controllers, that spares management, that timeline is always dictated by the manufacturer. We are saying, okay, this is when this ends, and you must switch to the next, the next generation of controller, for example. And when it comes to hardware independence, that means that we need to create build time and runtime environments that can be managed, can be run, and can be deployed on different hardware targets that are fit for purpose. And what that really opens up then is we can have a system where we have the same DCS runtime environment that's running, on your cracking unit inside your refinery. So you've got all of the high availability, disaster avoidance requirements that go on with that. But on the same network, using the same build time and runtime environment, we have an RTU that's sitting on a pump that's out in the field. So something much more simplistic in terms of the amount of compute power that's required there. Well, we can use the same runtime and scale it down to run there, rather than a not very cost effective to say use another DCS controller just to do this one pump application as part of the network. What that also means is then we can distribute the intelligence of the system, as I described, on those different nodes. So when an event happens in real time, those nodes can communicate with each other. But when it comes to disruption avoidance and disaster avoidance, that means that we can also land redundancy on a variety of hardware targets. So if you think about, a server environment where we have our main DCS system running and other pieces of software that are required for a plant to run, well, we can have a soft controller running in a virtualized environment on that server. So, control processor goes down, somebody bumps into the power supply. Well, we can recover within that network and have that backup really as a self-healing system within the server, rather than, again, going back to what I mentioned before, that rigid one-to-one relationship between that specific runtime environment and that specific piece of hardware. But it takes more than just hardware flexibility to call something open. And what we've been doing as well is thinking a lot and deploying a lot on the compute side. So what I mean by that is, of course, we've got our control environment. We have our loops, we have our control blocks, and so forth, standard that you would find in an automation system. But our customers are asking us more and more for the ability to deploy applications at the edge. So things like optimization, energy management, being able to dynamically manage more than just a single process from a controller, because you have all these other interactions. And so that also means in that virtualized control environment that's running on a ruggedized automation processor, well, depending on the compute requirements, maybe we put a higher horsepower automation processor in there because somebody wants to run an AI application to do some sort of an optimization loop. Somebody wants to be able to historize data locally and then move it using an IT protocol like MQTT into their overall IT network. All of these pieces start coming together for what becomes truly open, and having that level of flexibility and continuity when it comes to data management.
Yeah, that's very interesting. If you don't mind, let's take a moment and take a look at a classic DCS system and tell me how far off I am, because I am not a DCS expert by any means. But I envision a DCS system of the ones I've seen. You have these operator panels, which are really what people think of as the DCS system because that's what they see. But also near that, typically you have this huge rack, and that rack has a lot of connections locally, but also has connections to a bunch of distributed IO. And that is programmed and a lot of times using function blocks that are specific to, let's say, Foxboro or to the vendor, right? And they're very, very, some of those blocks are very industry specific, designed and, curated over time or refined over time that really address, like you said, maybe it's, making, steel, maybe it's doing some other type of process, right? And so when we think of a classic, how close did I get? Does that sound like a
That's
classic DCS?
that's very accurate. Absolutely.
Okay. And so as we look at that, we see some limitations, and I think we all heard it. People are like, I got this 30-year-old dinosaur and I don't want to replace it because it's going to be millions of dollars. And so with this new design, I kind of got some ideas from what you were saying, but with this new design, can you tell us like how what would a typical I would imagine a typical installation is going to look similar to the older ones, but talking about how we can distribute some of that, how we can leverage a different different automation processors. Can you talk about maybe how it's the same as that classic DCS, but then how, mentioning just some of the things you just said, how it could be different, like in certain applications.
Yeah, yeah, that's a very, very good point. So as far as the look and feel, if we walk through this, this plant of the future, if you will, using Foxboro SDA, you're still going to have servers, you're still going to have control room screens, you're still going to have operator interfaces. You might have some panel PCs for some smaller HMIs that are out in the facility. You'll still have controllers and IO. Those fundamentals always need to be there because we need to talk to things, we need to control things, and we need to compute. And obviously, then we need to present information to people in context, like the operators. So that is certainly, the I'd say the strongest piece of continuity in all of this is not to reimagine, some sort of movie like sci-fi interface for a an operator to control. And part of that continuity, importantly, is for safety purposes, right? There's certainly advancements in terms of graphics and what we can model, but when it comes to continuity for the operators, we want to make sure that that experience is as smooth as possible. It's what's underneath the hood that really then allows for some of this openness and flexibility. And I talked a lot about how we can deploy that build time on different targets. That also means for us, going back to kind of one of the points that you made, Shawn, it means for us to really break free from the way that we've conceptualized these systems over the past 40 plus years that we've been producing Foxboro DCS. That it's not using our proprietary build time and runtime and things that are only locked down to Schneider Electric. We co-developed our EcoStruxure Automation Expert software, which is what is running inside of Foxboro SDA, and that is the universalautomation.org build time and runtime. So we make that available even to our competitors that maybe is running on a different device, and that's using IEC 61499, which overcomes some of those legacy system limits, but still, you can still build a control block in it. Again, you have the flexibility to do things in ways that people are comfortable with, and that they're used to doing, with some learning curve there. But what it also opens up is when you think about the talent pool of control engineers, it's a small talent pool that we're all constantly trying to draw from. And if you look at from a talent perspective, the amount of new graduates that are walking out of college with computer engineering degrees rather than chemical engineering or mechanical engineering or control system engineering degrees, it's a much bigger number. So we also want to make this available that, hey, you can use Python to build out your control blocks. You can use, other IT tools that people are coming equipped to be able to use, that they can then go build and deploy on systems like this, and then free up some of the energy for those chemical engineers to solve, chemical engineering problems, not necessarily, spend their time building function blocks. So, really it's making sure that we have the compatibility outside of the Schneider Electric ecosystem, so that again we can land that build time runtime on other devices, including from competitors or switches that are in the network, things that aren't necessarily even considered automation processors, and then building out the openness when it comes to having this mix and match of different solutions that are, as I mentioned earlier, that are fit for purpose based on the control target that we're talking about. That RTU versus DCS example that I gave earlier, that really then becomes a big difference versus the paradigm that you described of where we would see everything kind of on a DCS, and maybe there's a protocol converter, or there's a field device manager that's then talking Modbus to other devices, and then you're using protocols to manage this rather than, again, fundamentally rethinking the architecture and then how that can get built out.
Yeah, and I appreciate you mentioning 61499 because we actually had Louis Arone on the show
Great.
back in 2022. So really 4 years ago, April 7th. And he would kind of introduce us to that. And I bring that up for the audience too. So if you guys want to hear that, I thought it was a great introduction. It's episode 96. So I thought it was a great introduction to uh that whole next gen of automation. On that side, we were really focused on 61499 and more of the other products. But this is a new product that utilizes that same base, right? And I think that's so exciting. Now, has anything been done? So you have a 40 years, like you said, of DCSs installed in the field. Is there any consideration made to how you bring those people, right, from last gen into this next gen product as we move forward?
100%. And I'm glad you asked that question, Shawn, because the philosophy that we've had both from a Foxboro perspective, even prior to Schneider's acquisition of Invensis in 2014, but also that Schneider Electric has taken with our PLC business and our RTU business, our SCADA pack business, is to never leave a customer behind. And that philosophy 100% has not changed. If we did take that tack, we would be making this announcement 2-3 years ago, because the complexity wasn't necessarily all these great things that I've been describing, and being able to utilize that universalautomation.org build time runtime, EcoStruxure Automation Expert. Those are, again, the fundamentals from the ground up. The challenge for us as a manufacturer is, okay, how are we going to manage the investments that we've been making in this? We've still been investing very heavily in Foxboro DCS in our current control system, that, and we will continue to do that. Certainly what we released recently with our Universal IO and our Edge IO line, all of that will continue. And we have customers who are already sort of coexisting some of this new system with some of their legacy system. We were at the ARC forum when we made this announcement in February, and we presented with one of our customers who, they use Foxboro DCS in a large chemical complex. They had a procedural automation challenge that we worked with them on, and we said, hey, why don't we use this build time runtime for this and use OPC to communicate with your Foxboro system? I said, great, let's try that. So that was a successful project. Now that's starting to expand into control applications for that customer, again, using that. So we're going to see a lot of some of this parallel activity. Again, as I mentioned, we're not obsoleting anything. We're not end of lifing anything. We're not leaving customers behind in this, but we are starting to, see some of these bright spots open up within our install base where, hey, there are some applications that doesn't require rip and replace. It's either a facility extension or a different automation challenge that maybe they wouldn't even think to solve with a DCS that we can now solve. And then over time, as older controllers do eventually become obsolete. I mean, we have customers who are running controllers who've been obsolete for 20 years and they're still ticking away in the field. But eventually, we have an inability to service something if it went obsolete in the early 2000s. So, eventually those things need to be replaced. So this convergence program that we built in parallel with all of this is really designed to work with customers at their pace, not a forced cliff from Schneider Electric, not a pigeonholing our customers into choosing a specific solution, but what's best for the facility. When are you going to take downtime to do a turnaround? When does it make sense to do some of this? Does it not make sense to do this maybe for 5 or 10 years? Okay, well, let's work with you and make sure that we can keep you running, we can keep you safe, and continue to service you. And that, again, has really been one of the more complex sides of all of this as a product developer, but one of the more satisfying ones as well is, ensuring that we've got that accessibility for customers at their pace, on their timeline.
Hey guys, just want to break in here for a second and thank Schneider Electric for sponsoring this episode so I can release it to you completely ad-free. And I also want to thank our members who make it possible for me to bring you episodes that are not sponsored by the vendor. And we have a number of those coming up. And so thank you, members. I get some new benefits coming to you later in the year. I'm working on it nights and weekends, so keep an eye out for that. But with that said, let's go ahead and jump right back into this episode of the Automation Podcast. Yeah, that's so important. I know as a consumer in my personal life, I get frustrated when legacy devices lose support after 2 or 3 years. It's so frustrating. I spent a lot of money on this. It's not supporting new apps or it's not supporting new software updates. And in the industrial realm, and a lot of these are CapExes, right? That is totally unacceptable. You gotta when you make a product, it has to be supported for decades, which of course Foxborough has done. And eventually the parts that go into that, somebody's not going to make them anymore. You're not going to be able to find a substitute. And that's why 30, 40-year-old devices do get obsoleted, right? Um, but in any case, one of the things you said that was so important to me was that this example you gave, where they had something, this customer who had an existing DCS system wanted to do something new, and you said, "Hey, why don't you look at this?" And so I know personally over the last 36 years, I've talked to a lot of DCS company customers who had something smaller they wanted to do. And they say, we're not going to disrupt the DCS system. This is our bread and butter. This keeps the place going. So we're going to put in like some kind of, you know, a third party system over here. So the two never interfere with each other. And that's a huge disadvantage because now you're having two support contracts, two different companies to work with, two different software packages. So I can see this is I mean, it just seems to make sense that it would be a great way if I had an existing Foxborough DCS and I had a small project. Hey, why not try the newest system on that smaller project? And instead of trying to go to some third party device. So I think you may see a lot of customers who take that approach saying, hey, we're not ready to do, a multi-million dollar project here yet, but we have these small projects. This would be a great way for us to evaluate this new system. So, can you speak more about that? Do you see that happening? And can you get the new system, right, at a lower entry level than you would the classic DCS system?
Yeah, that's absolutely. So, when I mentioned, I keep going back to my example, my favorite example of we've got a control processor on inside the refinery, and we've got an RTU on a pump, and I started my career, around these products with our SCADA pack product, our RTU, and again, that
Okay,
was before Schneider acquired that company, and
sure.
now I get to do both. So it's very satisfying. But that's also part of this is let's not force this rigidity and cost and complexity where you have to use a DCS processor and DCS IO when you need to do a different type of control in a network that doesn't require DCS, but you want it fully integrated into that DCS. And again, the way this problem would have been solved, with current systems, is you land that RTU or PLC anyway. You put a switch or a field device manager that can talk Modbus, and then you've got
Yes.
just basically points that you're pulling back. But
Yeah.
you don't have system management, you don't have system health, you can't deploy applications to that. You've got a different development environment, and so on and so forth. Even when you're using a PLC and a DCS from the same manufacturer, because again, those systems are different. And to your point, Shawn, the cost of entry is much different. So it doesn't make sense to deploy DCS processors everywhere because that would obviously inflate the cost of a system. So that was certainly part of the fundamentals in terms of the design side of all of this. And you're going back to your previous point where we see customers kind of early adopting this. Even before we branded this as Foxboro SDA and kind of came up with our entire DCS management around this, we started working with customers where they had those PLCs in the field that are talking Modbus, or your protocol of choice, your industrial protocol of choice, that have gone obsolete. It's maybe it was on an OEM package, and it's an older piece of equipment that that PLC isn't made anymore. Okay, Schneider, we want to take a look at how we can work with this. And that's where we can get really flexible with the deployment of this software and the flexibility then to integrate it into Foxborough DCS. What that also gives then is some other kind of eye openers for a lot of customers in terms of, well, how else can I use this software? Because it isn't just control software. We can use this to orchestrate multiple PLCs and use that as kind of a concentrator, and then get that information back into the system. I mentioned some of the procedural automation things that customers have done with this, as well from an IT/OT orchestration perspective, typically the answer of, how do I get my plant data into my corporate environment is you put it all into a historian, you replicate your historian in the cloud or in, your server in a corporate environment, and then you make calls from that historian. And there's very good reasons to do that for certain types of data. But there's also, we've been working with more and more customers where they want more plant data, but they don't have the capacity or the appetite to historize all that data, in their enterprise system. Whether that's point count limitations, whether it's speed, whether it's costs, they're looking for ways to, hey, I want to get all my vibration data from all of my compressors, into one database that then I as a developer can write some software around for optimization or for monitoring that really is outside of DCS. Well, that's another use of this platform is, again, that orchestration layer between the DCS system and the IT system that then, we can pull data out with using MQTT, using other protocols that are more or lighter from a transport layer perspective, and really allow for more flexibility of data movement. So, we've seen a lot of this kind of experimentation, and again, I mean, we're consuming this software internally to develop the control layer of Foxboro SDA, but all of this other flexibility exists, inherently within automation experts. So it's really exciting, and that's where we've seen a lot of this creativity, even applications certainly we haven't thought of. We learn a lot from our customers in all of this, and work with them to develop applications to move projects forward. The other thing that we've seen is there are a lot of customers who are building out either labs or test beds or smaller demo systems to prove out this technology. So that's the other area that we've been working with a lot of customers on is helping to develop those labs, working with some of the other partners, some of the other vendors at universalautomation.org, customers or companies, excuse me, like Phoenix Contact, like Intel, where we can land that build time, runtime on these different devices. The customers can test it out, and they can start thinking about some of these other applications of, okay, how will I solve, problem X that we know exists at this facility that we've, fortunately nothing's broken, so we haven't dealt with for a decade, and kind of really test things out and grow from there, before deploying it into the field. And also using it as a way, to teach some of their people on 61499, on some of the nuances that, are fundamentally different from a control standpoint.
Yeah, that's all very interesting. You brought up Modbus, and maybe 35, 40 years ago, people would get excited when their favorite vendor added Modbus as part of the driver stack that they could use, because it was kind of like the lowest common denominator. And it was just like exciting. Hey, now these two different products can talk to each other. This is great. We don't have to use ASCII anymore, right? So a huge step up. And it's just so funny. We interviewed Chuck Shelberg, who was one of the original engineers who designed the Monaco 84. He talked about how that came to be and how, the different numbering schemes came to be and came to represent what they were. And that eventually went over the network. But as you look back, you're like, this is the 21st century. We do want things like health. We do want things like, more rich data than just integers going across the wire, bits and integers, right? We want a lot, there's rich data that all these modern devices produce. And so staying with Modbus, it's still a tool in the toolkit, right? Just like the hammer, you can solve a lot of things with a hammer, but it's not as graceful as using a wrench in many cases, right? And so, be able to use OPC and more modern, Ethernet and other protocols, is such an advantage. And, when you're designing a new system, a lot of times you're like, do I really want to put in 50-year-old technology, 55, 57-year-old technology, Modbus as my, what does that say about the design, right? So I find that so very interesting. You also mentioned IO. We recently took a deep dive look on the Edge IO NTS platform. We worked with your people in France on that. Just a phenomenal system. But I guess I should ask you, as you're developing Foxboro SDA, right, and it's being deployed, what IO systems, and I know you guys have many, I saw them at the Innovation Summit, what IO systems do you see people using with this new system?
So that's another benefit, that we see from from, everything that we've been developing around this is when we're engineering let's call it, a brand new greenfield system where we don't
Yeah.
necessarily have some of the legacy limitations of what's at site. Being able to mix and match IO again based on the automation target. So
Yeah.
using that NTSIO, which is our simplex for PLC type systems,
Yep. Yep.
being able to use that with an appropriately sized automation processor for our tank farm for our PLC type environments, our discrete environments. We also developed and we released just recently Foxboro Edge IO NTH, so high
Okay.
availability. So a
Okay.
lot of the same areas of flexibility where we define, is it a digital input, is it an analog input, is it an analog output? It's all software defined, so it's configurable. The rack in, rack out slots that we have to simply change IO cards or expand them within a system. And then, of course, the head unit that allows us to talk to a Foxboro DCS system using
Mhm.
Edge IO NTH, and a Foxboro SDA system using Edge IO NTH. And as I mentioned in kind of my introduction, we continue to invest heavily in Foxboro DCS, and this is one example of
Mhm.
let's get the benefit of a flexible, smaller footprint, smaller power requirements, single IO card, and configurable, so you don't have to have all these different spares. Let's get that and make it accessible for our existing Foxboro DCS customers,
Yeah.
and let's get this ready to deploy, for Foxboro STA at the same time. And these are the kind of innovations that we'll continue to make in parallel. Again, work with customers on their timeline, but somebody who has an existing Foxboro DCS system can take advantage of these releases without touching their control code, without other than assigning IO,
Mhm.
not going in and having to redevelop anything, but make it simple to deploy, make it fast to deploy, and deliver that benefit as soon as it's installed.
Yeah, and we saw firsthand some of the benefits of the latest Gen IO, which, like you said, can be used with existing systems. You might say, well, why would I use the latest IO with the existing system? Well, that IO has benefits all of its own, regardless of what is the, automation controller that talks to it, right? And so that's a very interesting. You can, you don't have to think of this as an all or nothing, a rip and replace, right? You can upgrade components, even just IRACs of IO, and get a lot more intelligence that still works with the existing systems, which I think is so cool. Um, as
And
I'm going with God.
sorry to interrupt, but just another point I just thought of on that. When we designed that head unit for existing Foxboro DCS systems to talk to Edge IO, we also took into account the footprint of what would be in there today. So it's the
Yeah,
same exact footprint. The cables all line up. It's the same size in the
that's
rack.
huge.
So we're not asking for a re-engineer of your IO cabinets and different power supplies and things like that. It's like, again, let's make this modular, let's make it easy, and deliver benefits as soon as possible.
That's huge because you can't make the enclosure any bigger and you can't stretch the wires. So that same footprint, same lining up things, that is so huge and important, especially for those people who need to do a in-place migration of some of the hardware, right? Um, and a lot of times they do that not because the digital or analog IO is not sufficient. It's that they need more IO, or they need special IO, they need, fail-safe IO. They need some new feature that the new IO will bring them. So very important there too. And it just helps those, people building the panels and everybody else. It keeps everything the same and they don't have to redesign everything, slight, print updates, but not complete overhaul of everything. So that's so smart. We've seen that before, especially 10, 20, 30 years ago when new systems come out and it's like a complete redesign. So I'm glad that the Schneider and other vendors are trying to keep that same footprint and lineup. It makes everybody more efficient. Um, we covered a lot of ground in this interview so far. Is there anything else we should touch on before we close out?
Yeah, I think I mean, I could talk about this all day, as you can imagine, but I think one important note that we didn't necessarily come up in our conversation is cybersecurity. And
Yes.
when we start talking about openness and all of this exciting ability to deploy control code on different devices, you know, uh, for good reason, one of the first questions is then, okay, how do we secure this? And what we've been working on, and what we've been really from the very beginning had in mind from an architecture perspective, and invested from a design perspective on, is to ensure cybersecurity at every layer when it comes to Foxboro SDA. So that means SL2 certification on devices. It means SL2 certification on the entire system. And if we're putting that Foxboro SDA label on it, here's your design validated architecture from Schneider Electric. Within the boundary conditions of that designed architecture, we are certifying that, and ensuring that the confidence that customers can have from a cyber perspective, meets or exceeds what they have from a standards system capability expectation. The other thing that we have, is, I wouldn't call it necessarily a cliff event, but for our European customers, there's the Cyber Resiliency Act, which is, we're marching towards in terms of timeline. So that was also, part of this is maybe let's overbuild to a certain extent from a cybersecurity perspective, so that we can meet that Cybersecurity Resiliency Act requirement that's coming. And I'm sure we will start seeing, versions of that start popping up in other parts of the world. And certainly there are manufacturers, customers like BASF as an example, that are a European company, and other customers that we work with around the world, where they have specific standards bodies that they work with. They dictate to us what their cybersecurity requirements are, and we ensure that we are building, and we are designing, and we're engineering to that standard.
Yeah, and it's for the Americans listening in, which I think is most of us. I mean, we've talked about this before, how Europe, they started talking about security, cybersecurity in manufacturing and automation, really for around critical infrastructure, which is a great place to start. But over time, they've widened it to include infrastructure that could have a huge, devastating impact on the society, and that can include things like, you can see in the future water and wastewater and other, not just utilities though, but chemical plants, and even, some things you wouldn't think of, but if it, we saw it here a few years ago where a pipeline was disrupted with a ransomware attack, and the price of fuel, tripled overnight, and so that's kind of giving you the idea of where they're going. And of course, I think in America, we're more like, all right, companies, you need to protect yourself or you're going to get sued. But that's still a good idea, because if you look at the companies, and I've talked to so many people on and off the record who've suffered a cyber attack in their company, and it's devastating. So security here's to stay. I also like talking about 62443, which is, from the ISA. We had them on back in episode 110. So it's another thing to look at, folks, if you're interested in cybersecurity. That's really developed by the ISA to help people who aren't in Europe, but try to meet those same standards and get to that same level. And so, as we say on the show, zero trust. That's your friend, right? So, no, that's all very interesting. Anything else we didn't touch on that we should cover before we close out?
Oh, I think this was a great discussion, Shawn. We're always happy to participate in your program, your network, talk to your audience. We really want to make automation as accessible as possible. Whether that's on large installations, whether that's for our existing customers or for our new customers building. So really, really appreciate the opportunity to talk about this.
Well, I really appreciate you coming on. And I also want to reach out to the audience and say, what else do you want to know about Foxboro SDA? Did I get that right? SDA, right? So
Absolutely.
what else do you want to know? And let us know. We'll send it out to Elias. Maybe we'll get him back on to answer some questions, or we'll get him to send over some text. We'll post it as a blog post. But love to know what you folks in the audience are interested in, would like to know more about. Again, not being from a DCS background, I'm going to rely on you guys in the audience to let us know. So, Elias, I want to just thank you again for coming on the show. Really appreciate it.
Thanks very much, Shawn.
Well, I hope you enjoyed that episode. I want to thank Elias for coming on and telling us all about the Foxboro SDA DCS. I also want to thank Schneider for sponsoring this episode so I can release it to you ad-free. And I want to thank our members who support my work so I can bring you episodes that are not sponsored. With that said, I want to wish you all good health and happiness. And until next time, my friends, peace.